If you're a manager in tech, you've definitely heard the term DevOps thrown around. But what does it actually mean for your team, your projects, and your bottom line? Well, today, we're going to cut right through the jargon. From my perspective as a solutions architect, I'm going to show you exactly how DevOps takes a brilliant idea and turns it into a real-world product, faster and more reliably than you might think.
All right, so let's start with the classic problem, the before picture. Traditionally, you had two groups kind of pulling in opposite directions. Your development team, their whole world is about building new stuff and shipping features fast. But then you had the operations team. Their main goal, keep the lights on, make sure everything is stable. You see the problem, right? This creates a natural tension, a wall of confusion that just leads to bottlenecks, friction, and let's be honest, a whole lot of finger pointing when things go wrong.
And this, right here, is where DevOps steps in. Now, let's be super clear about something. DevOps is not just a tool you buy or a new team you hire. At its heart, it is a cultural shift. It's all about breaking down those walls, getting dev and ops to work together, focused on one single shared goal, delivering real value to your customers as quickly and as smoothly as possible.
We often visualize DevOps like this, an infinite loop. Because it's not a straight line with a beginning and an end. It's a non-stop cycle of improvement. You plan something, you create it, you verify it works, you package it up, you release it, and then you monitor it. And here's the magic part. Everything you learn from monitoring feeds right back into the next plan. It just keeps going, getting smarter and more efficient with every single loop.
Okay, to make this less abstract and a lot more real, let's do this. We're gonna follow the journey of a single new feature. We'll trace it from a simple idea on a whiteboard all the way through this lifecycle until it's in the hands of your customers. This will show us the real-world problems that DevOps is built to solve.
So, our journey starts with the code itself. But picture this. You've got 5, 10, maybe even 100 developers, all working on the same files at the same time. How on earth do you prevent them from overwriting each other's work and turning the whole project into complete and utter chaos?
The answer, and really the foundation that all of this is built on, is something called version control. Think of it as a system that tracks every single change made to the code, making sure everyone is working from the exact same playbook.
And the undisputed king of version control is Git. You can think of it like a super-powered history book for your code. Every developer can have their own copy to work on, and Git is the tool that expertly helps merge all those changes back together. Then, you have platforms like GitHub or GitLab. They act as the central library, the one single source of truth where the official master version of the code lives.
Great, so our developers have written their code and it's all merged together nicely using Git. But here's the thing, a folder full of text files isn't a working application just yet. It has to be compiled, tested for bugs, and packaged up for release. Doing all that by hand is incredibly slow and, humans make mistakes. So the big question is, how do we automate this whole process?
The answer is CICD. It stands for Continuous Integration and Continuous Delivery. And if DevOps is the philosophy, then CI/CD is the automated assembly line that brings it to life. It's the engine that creates a smooth, automated pipeline, taking code from a developer's keyboard all the way to the customer.
You build these pipelines using tools like Jenkins or GitHub Actions. Now imagine this. The moment a developer pushes new code, this pipeline automatically springs to life. It grabs the code, builds it, runs a whole battery of automated tests, and if everything looks good, it packages it up for deployment. The result? Your code is always in a state where it's ready to be released. No more last-minute scrambles.
And now we hit one of the most classic and frankly, most frustrating problems in software development. Your developer says, hey, the new feature passed all the tests on my laptop, but then you deploy it to the live production server and it completely breaks. Why? Because the server environment is different from their laptop. This is the dreaded "it works on my machine" problem.
The solution is just genius. It's called containerization, and you've probably heard of the main tool here, Docker. The best analogy is a standardized shipping container. You know how those can be loaded onto any ship or truck? A Docker container does the same thing for software. It packages up your application and everything it needs to run, all the libraries, the settings, you name it, into one neat little box that will run exactly the same no matter where you put it. Now, Docker is so incredibly effective that it creates a new kind of problem. A good problem to have, but still a problem. It becomes so easy to create these containers that you start using them for everything. And suddenly, you're not managing 1 or 2 servers anymore. You could be managing thousands or even tens of thousands of these little software containers.
So that leads us to our next big question. How do you possibly manage this massive fleet of containers? How do you make sure that if one of them fails, another one just pops up to take its place? And how do you automatically add more containers when traffic spikes and then remove them later to save money?
The answer is something called container orchestration. And the industry standard, hands down, is Kubernetes. Think of Kubernetes as the air traffic controller for all your containers. It's the brain of the operation. It handles scheduling them, healing them if they get sick, scaling them up and down. It takes this chaotic fleet of thousands of containers and makes them act like one single, powerful, resilient system.
Okay, this is great. Our app is neatly packaged in containers, and Kubernetes is managing them beautifully. But what are all these containers actually running on? They're running on servers, networks, and databases. And setting up all that underlying infrastructure by hand is slow, expensive, and a recipe for human error.
The DevOps approach to this is brilliant. Just treat your infrastructure the same way you treat your application. In other words, turn it into code. This is a practice we call infrastructure as code, or IAC. You write down exactly what you need, your servers, your networks, your security rules, in configuration files. And once it's code, it can be versioned, tested, and automated.
Let's stick with an analogy. Tools like Terraform are used to provision the raw infrastructure. Think of this as building the house, pouring the foundation and putting up the walls. Then, tools like Ansible come in for configuration management. This is like furnishing the house, installing the appliances and setting everything up just right. Using them together means you can rebuild your entire environment perfectly with the push of a button.
Whew, okay. Our feature is officially live. It's running in containers, orchestrated by Kubernetes, on infrastructure that was built from code. We did it! But wait a second. How do we know if it's actually working? Are customers getting errors? Is it running slowly? Are we just flying blind here? This is what closes the loop.
This brings us to the final, crucial piece of the puzzle: monitoring and observability. This is how we get feedback. Tools like Prometheus act like sensors, constantly collecting performance data, metrics, from every single part of your system. Then, a tool like Grafana takes all that raw data and turns it into beautiful, easy-to-read dashboards. It's like having a real-time health monitor for your entire application, letting you spot problems long before your customers ever do. And that brings us right back to the most important point of all. We've talked about a lot of cool tools today, but remember, the tools are just there to enable the culture. DevOps only truly works when everyone, your developers, your ops team, your security people, even the business leaders, feels a shared sense of responsibility for the product. It really is a team sport.
So we've walked through this whole journey, and as a manager, I know what you might be thinking. That's a lot of technology. But what's the actual business payoff? Why go through all this trouble? Let's talk about the real, bottom line impact.
Here's the whole shebang. First, speed. You get new features and ideas into your customers' hands way faster. Next, reliability. You have fewer outages and happier users. Plain and simple. It lets you scale complex systems without having to triple your team size. Security is no longer an afterthought. It's baked in from the very beginning. And maybe most importantly, you build better, more effective, more accountable teams because everyone is working together. Look, DevOps isn't a final destination you just arrive at one day. It's a continuous journey of improvement. It's about always looking for the next bottleneck, the next manual process to automate, the next wall to break down. So I'll just leave you with this one question to think about. Where is your team on its DevOps journey, and what's the very next bottleneck you can remove? Thanks so much for your time.